All right, it is day 14 and we are going to be practicing the same skill that we learned on day 13. So we've already taken our notes on converting equations from standard form to slope-intercept form, and today is going to be the practice for that. So there's going to be quizzes for you to complete. It's multiple choice, which is why you really need a separate sheet of paper so you can write down your work, and then you can kind of match your answer as you go. So very quick reminder, we've been working with slope-intercept form for quite some time now. Y equals mx plus b, where m represents your slope and b represents your y-intercept. And that makes our life a lot easier when we go to graph these equations or when we're going to look at how things are changing or compare two equations to each other. So in this example, it's given to you in standard form. And what that means is that your x and y variable are on the same side of your equation. So our whole goal in getting our equation into slope-intercept form is to have that y isolated. So if I look here, I have 3x and negative 2y both on the left side. So our goal, remember those steps that we've already taken notes on, is to get this y, this variable right here, isolated. So we need to use inverse operations and the property of equality, which means we do the same thing to both sides, to get this isolated. The first thing we're going to take care of is that x variable, because if we notice, x is already on the right side, but it's on the wrong side here. And to do that, just like we would when we're solving equations, if we have 3x, in order to get that back to 0, right? If you have $3, you have to spend $3. If you have 3x, we have to subtract 3x. But again, property of equality. What I do to one side of my equation, in order to keep this balance, I have to do to the other. Notice where I line it up. It is not directly under 12. And that's because 12 is a constant and 3 has an x next to it. So these are not like terms. So when I go to take care of my arithmetic, 3x minus 3x is 0. And I need to bring down negative 2y. I bring down my equal sign. And then I have the expression 12 minus 3x. I can't subtract those. They're going to stay 12 minus 3x because those are not like terms. So we're starting to get it to look like this, except y shouldn't have a coefficient, or the coefficient should be 1, right? We shouldn't have to see it there. But I see a negative 2, which means that invisible operation right here is multiplication. The inverse of multiplying would be dividing. Here's where it's super important that you do the exact thing, the exact same thing to both sides. And what that means is wherever you're dividing by negative 2, it has to happen to every single term. So negative 2y gets divided by negative 2, 12 gets divided by negative 2, and negative 3x gets divided by negative 2. So I've actually made 3 individual division problems, right? Or 3 fractions. I know negative 2 divided by negative 2 will give me 1, which was my goal. And I'm bringing down y on this side, which is perfect. That's what I want. But now I have to do the math. I have to simplify these fractions. I have 12 divided by negative 2, which is negative 6. And then I have negative 3 divided by negative 2. But we've talked about this. If you're dividing a negative by another negative or multiplying a negative by another negative, those negatives actually give you a positive. So negative 3 divided by negative 2, well, I can't simplify the fraction itself. That's actually a positive 3 over 2. And then I have to bring down my variable, which is x. So, quick check. Y is isolated on the left side. It's starting to look like slope-intercept form, except we're missing one last thing. My mx comes before my b when it's in slope-intercept form, which means the one thing I need to do is rewrite it with x coming first. I have to keep the sign in front of the term the same. So if I look at moving 3/2 x in front, I notice it's a positive. So 3 over 2x is going to stay a positive 3 over 2. Then I look at my y-intercept, which is negative 6. I have to keep that sign with that 6, so we're going to bring down minus 6. And the way that I know that I did my work right is that I'm able to determine what my slope is and what my y-intercept is from this equation. Now don't forget, the equation started out like this, 3x minus 2y equals 12. This is the exact same equation. It's just written in a different form. And I know that my slope would be positive 3 over 2. In other words, my line is going up 3 units and over 2 units the entire way. And I also know that my y-intercept is negative 6. So if I'm looking at that vertical y-axis, I know the first point that I'm looking at is down at 0, negative 6. So I would be able to graph that. So there is your one example. If you need to go back to day 13 where we had the longer video and we filled in the notes, please do so. Otherwise, after you watch this video and write down this example, you have a quizzes to complete today. All right?